All right. So
yeah, this is our autonomous race car senior project. I'm Derek, an electrical engineering major here at TCNJ.
Yep. And I'm Michael. I'm senior computer engineering major.
So starting off with the project overview. So our goal for this project was to redesign a conventional remote controlled car. And we're going to implement two different driving modes. So one is going to be manual navigation, which is controlled by a user using a tablet, which we have right here, to basically specify a command to make the car go forward, backwards, left, right. And then we're going to use that mode of navigation to basically control or train a convolutional neural network with the NVIDIA Jetson. And we're also going to try to maximize our speed and performance capabilities as if we were trying to get this race car ready for some sort of race. So yeah, next slide, we have some detailed specifications. So we have the dimensions of the car, the minimum speed we're trying to achieve, the runtime, the minimum object detection range would be if we're implementing some other sort of sensor, such as an ultrasonic sensor. But our main way of basically getting the car ready for autonomous control is through a camera, a Raspberry Pi camera. And then, yeah, we also have the weight limit and the IP rating. So this is the system architecture. It's basically a diagram that was made in MATLAB. So on the surface, all there is the either phone or a tablet sending a signal to the RC car to make it either forward, backwards, and underneath is where the Android app is on the phone, and then the RC car contains the Jetson, which is the brain of the whole system. And then around that, you can see there's the camera, the motor, the ultrasonic sensor, and the servo components. So for the mechanical design, we bought basically a pre-built chassis, which was disassembled. However, most of the components were used that came with the car, such as the ESC, the servo, the DC motor. We also needed new components though to implement our design, which some of them were the lithium-ion battery, the MCU, which is the Jetson, a PWM board, and a camera. So at the bottom, you can see the bottom left is what the car looked like when we first purchased it. And the controller is in the middle, so it used just a radio controller, 2.4 gigahertz frequency to control it. So we basically ripped out that type of controller. And then what was left is we also took off the frame of the car because that's obsolete for our purposes. We're not going to be able to put the Jetson on top with that still on the car. But you'll see our design in the next slides. So this is the MCU. We went with the NVIDIA Jetson. We compared it with others like the Raspberry Pi and the Arduino, but this was selected solely because of the power that it has, and we were able to get it for free. We didn't have to use any of our budget. We also selected it because of the pins it contains and the computer vision that it has. So this is the sort of the power distribution of the components. So we have two circuits for the Jetson. One is just we needed to use that lithium battery to basically make the Jetson portable. We can't use the original power supply if we want it to be portable and not plugged into a wall. And then the other circuit is kind of what already came with the car, but it has the drivetrain motor and the ESC. But then we also have that connected to PWM. So everything is sort of connected through that to send duty cycles to the components so that it controls the race car. And then we have two different batteries. So you can see they're both 7.4 volts, but there's a much greater amperage for the Jetson. It's just a bigger battery, basically. So this is what the complete car looks like with the casing that was constructed last year. So we reused that casing, but we have a different race car chassis for our purposes. So one issue was since we wanted to reuse the casing, which basically houses the Jetson, the battery, the PWM, and such, we needed to sort of take it off of the old chassis and drill in new holes. But the chassis that we currently have, it's not as wide, so we had to basically only connected to the one side. So the red circles is where it's drilled in currently, and the other two black circles are where it's basically hanging off the car. So there's not really a good distribution of the weight. So this is just something I recently was working on. I kind of made a draft of like a platform that the casing would sit on, and I made a like a basic SolidWorks model of it as well. But this picture on the left, the drawing is like the top view and then the side view. These are like the columns of the casing that it's gonna that it's used to attach to the car through screws as well. So now we're gonna get into the mobile application and the Android tablet.
So basically what I'll go through is kind of all the software-based systems that we currently are using for the car. So originally, like Derek was mentioning before, obviously when you buy a little race car, it comes with your controller, does the basic stuff for it. But what we decided to do instead is kind of rip that apart, become a little bit more modernized, and decide to use a tablet instead to control. This is just an example right here of the application that's currently being used with the Jetson. So essentially, what we're trying to do is the overall goal is to be able to collect as much data as we can by running the car around, and we're controlling it with this application right here. After we gather enough data, and so we will be able to run the machine learning model, which I'll show you guys in a few minutes. Once we're able to do that, then it could drive itself autonomously, right? Kind of like along the same lines of like having the car kind of already know when to turn left and when to turn right accordingly. So everything that you see in the left is insignificant to us today. Those are just kind of everything that it takes in order to have that joystick running, in order to have the little controller running. And this is an application that's still in the works. You'll see that it doesn't have the best design just yet. So it's still in the works for that. But then with that design, we're actually able to get it right here. So this is the tablet that we're currently using to run, hopefully to run that car, right? And then as you can see, you can kind of change like the speed of it. So as you're going up, that is essentially what accelerates the car. And then if you move the joystick around, that's where it turns left, right, and all that. But it's much easier to do a landscape as well. So you can also do that landscape. If you look into the app, it's not shown here, but it says Bluetooth connection. So it's waiting to get connected. As of now, the tablet is currently connecting through the Jetson board via Bluetooth. So the first thing that you will see here when you click connect is the nearest devices that we see over here. And the nearest device would be the Jetson board. So that's where it would try to connect. And then that's where it would have that communication over. So there is that. And then what we've tried to do is run separately first the machine learning model of that. So this is currently, we're using the Jetson board right now. So basically to talk a little bit more about the Jetson. So it's basically a juiced up Raspberry Pi. So Jetsons where the Jetson board has a whole family and things that were made by NVIDIA. And so we essentially found out that the Jetson boards have a lot of better tools and mechanics when it comes to machine learning, when it comes to AI. It already comes with a lot of pre-built samples. So in order for computer vision or anything like that, it already has everything of that. So that's why we went over this route. And then we'll be able to demonstrate an example right here. So yeah, so don't worry, this isn't gonna run for 3 minutes. I'll just make this faster and kind of talk over it. So this is me currently working on it right now. What we're trying to do is first find where the script is to run the machine learning model. So you can see here that I'm currently going through the directories, right? Figuring out where exactly that script is, you'll see that it has a bunch of Python scripts and CSV files. So when this tablet starts connecting to the Jetson, it records the CSV values, because the CSV values is where you'll find kind of like the angle directions, the angle speeds from the car. So as it's driving, it's able to record it from the tablet and have it posted in a text file, right? So you'll see here that it's currently running a machine learning model, and it's running through 25 epochs. So an epoch basically means running through a complete cycle of machine learning model. So pretty much what happens is once that's done, it's able to give us an output of like how accurate it is trying to feed in the data. So it's currently only taking literally one sample that we've used at this point, like one test run that we've had that a car is moving and that we're moving it around with the joysticks and stuff like that. So this is just one example of one trial that we're using as a sample. And throughout the running process, you'll see that there's a validation loss value and a regular loss value. What that basically means is that when we get the output in a few seconds, it's supposed to tell us how accurate it is when it's feeding into the data versus how it's able to read that data. So you'll see that the last part there real quick. And truth be told, that last part that we see here, that's not really a real proof of this running, because again, this is just based on one single sample. So you'll see that in the beginning, it's a really high loss percentage. So that 80% loss, that basically just means, hey, I'm feeding the data into the computer, but I have no idea what I'm doing, right? That's coming over from the first few iterations that it's running the machine learning model, but then eventually it catches on and it goes up to 0%. So then it's like, okay, I read this data 4 or 5 times, and then for the remaining 15 times that I'm running the model, I know what I'm looking at and I know exactly where to go from there. So that's the model itself. But a lot of with the confusion with machine learning, right, is what exactly is it feeding in? So there's 2 things that it's taking into consideration when it's running the machine learning model. Previously, the only thing that I had done was it was able to figure out the directions based on pictures. So every single frame that you see here is probably from like a 10-second video that we recorded from the camera. So all that 10-second video gets divided into all these frames right here. And that was the only thing that it was reading into. But the one thing that we changed is that now we're also feeding in those CSV files that I had mentioned previously. Because the CSV files, you'll see that there's a bunch of random numbers on the right. And that just means the angle directions that the car was going at, right? So it's taking those 2 things into consideration when it runs through the model. So hopefully what we plan to implement is, obviously record more data for the car. And then once we have enough data, we can finally take that car out and drive it around. Or hopefully it drives by itself around. So that's definitely one of our next goals for that. Further into the slides. So this is kind of like what we're getting into the conclusion, what we've done so far. So all the components and pinouts, we've already figured that out. Basically what we did was, since this is a legacy project, this wasn't previously made. This isn't from scratch from us. This is from a project that was done before. There were a lot of, little things and mistakes that were done before where we basically broke the whole car apart. We broke the whole car apart to analyze it, to figure out where those pinouts were going to, like why, because there were certain like connection issues and connection failures. So we were able to pin that out and figure that out through that. So now everything is disassembled, and now the next goal is to put everything back together, get that data up and running, And then what we hadn't done previously was done the neural network. So that was more recent what I did, that we created the model where it gives us like the machine learning aspect of it. Because the only accomplishment that was done previously was actually getting the car running from the tablet onto the Jetson board. So there was only 1 or 2 samples that was recorded. So, but there was no neural network script just yet. So now that that neural network script is done, now we can go back, record a lot more data than what was previously recorded, and get that set up for the actual autonomous part of the car. I'm just concluding the box. Yes.
Yeah, so currently our goal is like finishing up that manual control and preparing it for the neural network training. And the main method of data collection is through the camera. But we do want to try to implement other sensors if possible once we get that working, to get like a more accurate autonomous driving capabilities. And then I just said the lone camera might not be sufficient to get it to do what we really want it to do in the end.
Yeah. Also, one thing to consider, because I know someone's probably thinking to themselves, how far is the connection between the tablet onto the Jetson? It's not that far as of yet. So I think once we figure out the longest range that it could get into between the Bluetooth connection here and the Jetson, we might have to do like some antennas for a better Bluetooth connection and a longer Bluetooth connection. Because one thing we wanted to try was that it is a race car, right? So we wanted to take it to our track and field area that we have here and kind of like drive it in a loop and see like how well it does from there. So for that, we probably might need 1 or 2 more antennas for a better Bluetooth connection. But that's basically it. Does anyone have any questions? Yes.
So what scale is this car? Is it like a life-size car or like more scale like RC car size?
Oh, so yeah, so we presented on the beginning. It's more of an RC car, so it's like yay big, like this. So yeah, yes.
Talk about the models.
So it's very I would say it's very arbitrary, and it's very like it's something that you either get right or get wrong, if that makes sense. Because so with the model, I wish I had a demo for that, but you'll see that. So we use the TensorFlow framework, if you're aware of that. So literally any value that we change could change the whole spectrum of the network. So because I had previously, that's kind of like my area, what I've always liked to do. I've done a lot of machine learning stuff over the past few years. It's just based on prior knowledge, what I think is best when it comes to like OpenCV and image processing. So there's a wide range of architectures that you could really use, but I kind of spent a good amount of time figuring out what the best architecture was. So right now, the model currently runs on a 4-layer network. So that basically just means that the video that we're capturing, it's splitting it up into 4 main layers. And then from there, it analyzes each frame from the video. And then that's where it gets processed. And then that's where it gets fed through in the machine learning model. Yeah. Yes.
What was the chassis you used for the or was it just mainly all in-house events?
Besgar IPX, just like standard like remote controlled car. Yeah.
Those guys sponsored? Yeah, that's sick.
Yeah.
That's funny. It's crazy. Yeah. But yeah, we the base chassis is already there. Kind of what we're doing now is I know Derek mentioned a few things like the PWM and the ESC. That's like the speed controller and the pulse width modulator. So having those connections go into the Jetson board as well through the pins. So that's one of the things that we figured out, like what are the proper pins to use for the Jetson board. So, and we had to actually reconfigure certain pins because you could customize some of those pins that are in the board. So we had to configure those to like have that connection between the PWM and the speed controller. Anyone else?
Yeah, that was just strictly for the diagram, like
That's
the
strictly for
block diagram of the system architecture.
Yeah. No.
No, not in that lab, no.
Yeah.
That was like Simulink that was really used for that, yeah.
Got a question? Oh, no. Okay. All right.
All right, well, that's it. Thank you
Yeah,
guys
thank you,
for
Rob.
coming and listening.